All right, welcome to program 4, and we're going to talk about, this is program 4, inventory. So let me make sure, oh, I don't like that color. All right, let's get a better color here. Program 4, the inventory program. This is an array of structs. So in this program, we're going to talk about and give you some hints to help you start working on your project. All right, so these are the functions that you need to use. You need to do a function that greets the user. You need a function that hard codes 6 entries into the program. You need a function that runs the menu and gets the choice. You need a function that prints all of the contents of the list onto the screen. You need a function that prints a report to the file. So please pay attention here that you want to declare the file pointer, connect to the file, and close the file pointer all inside of this function. And the reason that you want to do that is because you want to make sure that you create a new report each time. You need to write a function that adds an item to the list, a function that displays the IDs in the list. So if you looked at the other video, you could see in the video how it displayed all of the IDs, and I also did the ID and the song title. You're not required to do the ID and the song title. You're not even required to do a song, but it helps the user then have them just look at an ID. You also need to write a function that searches through the list, that takes that ID that was returned from here and searches through, and it will return the location. So if there's a match, it's going to return the location, so you know which one you're going to be deleting, or it will return a -1 if it is not found. You have to be careful with the -1 because it is not possible. Say, for example, your data type is student and you have a list of size 40. It is not possible to have list at index -1. So it's very important that you check for that this does not happen. This is very bad, and it will cause your program to have crash or to have really serious issues, because if you think of an array and your array is called list, it starts always at index 0, index 1, index 2, etc. So it's not even possible to have an array that has an index of -1. So be very careful about returning this -1 here. Then you need a function to delete and a function to update. You're not required to update the sale price. You're just required to update some option in the list, not the ID. You cannot update the ID because that's how you find things in the program. All right, so let's go to the next slide. So here are the step-by-step instructions. First thing is to take a look at the program and to write the algorithm. In this case, you are not going to be turning in the algorithm, but you still probably need an algorithm in order to understand the order in which things happen and to make sure that to help you to get started. You do not turn in the algorithm. Do not submit the algorithm. It is only for you, for this assignment. All right, so the next, you create your project and you set it up with your preprocessor directives and you make sure it's all set up. So the next step is to create your structure. So your structure is going to have 2 character arrays, 2 integers, and 2 doubles. Mine, I'm just going to have 1 character array, 1 integer, and 1 double because I'm writing on the board and it's less complicated that way. So after you have up here your preprocessor directives, and in case that word is too fancy for you, all that is the pound include stdio.h, pound include string.h, pound include string, C type. I think that's all you need, and pound define size 40. All right, then in your main function, then your preprocessor, well, I better put that here. So then up here, your function prototypes go here. Your prototypes will go Oops, I have already messed up. No. First, we got to define your structure, then your prototype. So your structure gets defined right here. So you use the keyword typedef and the keyword struct, and it's a block of code. So it has an opening curly brace and a closing curly brace. And the name of my struct is student with a semicolon. And the fields that are going to be inside of my student are going to be a character array called last name. And there will also be an integer for the ID. And there will also be a double for the GPA. So what you need to remember is that you're going to define this structure, and yours is going to have 6 fields instead of just 3 like mine. Then below that, you will put your prototypes. And below that, you will put your main function. And below that, you will put your definitions. All right, so you define your structure, and then you build it and test it, and you make sure that you have a structure and it compiles and everything. You don't have any syntax error. All right, so the next step, we've done that. Now the next step is to implement the greeting function. The greeting function I'm not going to do for you. All you need to do is greet the user from inside of your main function. So now I'm going to go to the next slide. And just to remind us that we have our struct. So as I'm continuing on here, this is not complete code, but this is our struct. We have a char last name, an int ID, a double GPA, and the name of it is student. All right, so when I'm in my main, you're going to have your prototypes and your definitions and everything, and when I'm in my main function here, all right, so it says to declare an array of your new data type. So in my main function, I'm going to write my new data type, which is student. And I'm going to give it a name. So I'm going to call it list. And I already did the pound define size 40. So my list is going to be size, which is 40. And I also need to declare a count or a number that keeps track of how many students I've actually placed into my list. And at this time, I have no students in my list, so the count is going to be 0. So now I've declared and I've initialized my count to 0, and I am ready now to implement my hardcode 6 function. Now my hardcode 6 function, I'm going to call add 6. Now the reason that we're going to put 6 items into our list is because if you don't put 6 items into your list, every single time you want to test how to print, you want to test how to delete, you want to test how to add, you're going to have to add data into it. So if you add 6 items into your list from the beginning of the program, then you should not have any problem following along and doing your print to the screen and your save to a file and your clear your list. But what you need to do is, as you are doing these different options, you need to remember to build, run, and test, build, run, and test, build, run, and test, build, run, and test. And also be sure to add printf statements all over the place so you can follow what's happening. All right, in the next slide, I'm going to do the add 6 function. The add 6 function. So this is the function definition for add 6. This function is going to take as its argument a student array called list. You can name it whatever you want. List will be the local name for this function. It's also going to be the name here. So actually I have this list, and in my main function it's called list, and in this function it's also called list. But sometimes it's a good idea to make the same name, because in this case, I don't have some random kind of generic student array. I have one student array that I'm using throughout my entire program. This function doesn't really need to return anything, so I'm going to show you now how to fill data into your student list. So if you remember our fields, we have an L name, which is a character array. We have an ID, which is an integer, and we have a GPA, which is a double. So the way that you fill it in, if this is my list, this is list at 0, this is list at 1, list at 2, list at 3, list at 4, and list at index 5. So what I want to do here is I want to put, for example, I want to put a last name here like Jones and an ID and a GPA. And I want to put a last name here like Smith and an ID and a GPA. I want to put a last name here like Wood and an ID and a GPA. All my students have a 4.0. And I want to do it for the first 6 items in my list. So how do I do that? Well, all I do is I assign the information. The only key here is that when you are dealing with a character array, you cannot assign. You have to use string copy. So I'm going to have to string copy. Let me fix that P, it's a little ugly. So I'm going to have to string copy into my list at index 0 dot L name. So that's this field right here, the last name at index 0 of my list. I'm going to put in there the name Jones. And then I'm going to assign list at index 0 dot ID, the ID. And then I'm going to assign list at index 0 dot GPA, the GPA. So this is list at index 0. So this list at index 0 right here has been filled. Now I want to continue. So I'm going to do list at index 1. So I'm going to string copy into list at index 1 dot L name Smith. And I'm going to go to list at index 1 dot ID and assign the ID. And list at index 1 dot GPA. So all you need to do is you need to do each one of these. So now I've done list at index 0, I've done list at index 1, then I need to do list at index 2, index 3, index 4, and index 5. And then I've filled 6 hard-coded information has been filled into my list. And then I will be ready to try to print it onto the screen and add things to it and delete things from it. Now the most important thing though, when you are in your main function here, oh, I don't like that color. When you are in your main function and you have your student list, that's capable of storing 40 items, and you have your int count, that when you have nothing in your list is a 0, but when you call your add 6 function, and this is not the only way to do it, but this is one way. When you call your add 6 function, be sure after, now that you have 6 items in your list, you need to make sure that your count knows that you have 6 items in your list. Now why is that important? Because this variable count right here is the one that's going to decide where you put the new item in, where you add one, how many is going to be printed onto the screen, how many items are in your list. If there are 6 items in your list, count would be 6, and they would be at indexes 0, 1, 2, 3, 4, 5. If you have 5 items in your list, count would then be 5, and they would be at indexes 0, 1, 2, 3, 4. If you have 9 items in your list, then count would be 9. So the requirement for this assignment though is to add 6, and then you assign your variable to be 6 after you've added them in. So we've gotten right here where we have implemented the hard code function, and it's really hard to know if this is actually working. So you will not know until you actually implement your print to the screen function. So the idea here is to follow step by step, add printf statements. The point of this assignment is to learn. It's not just to take pictures of the screen or the board and then type it in without thinking about what you're doing. You need to follow along and think what you're doing and learn how to ask specific questions so that you can get help and continue to progress. Be sure not to try to do everything at one time, because you will end up having to go backtrack and comment things out to figure out where the problem is. Be sure to build, run, and test after each change that you make so that you know that at that point it's working okay.